Welcome to our discussion on per unit quantities. This is the first in a series of videos I've done on this topic. It's a very important topic in power system analysis, and that's why I want you to really understand the basics of this well. In each of these videos, I will dig deep into a certain topic and solve an example and leave you with a sample problem at the end. So let's begin by defining what per unit quantities really are. Now we're very familiar. There are two ways. So let me begin by saying that there are two ways of defining electrical parameters. There's one way which we're really very familiar with, which is the units, which we use very often, which we're familiar with. So for voltage, you have volts. For current, you have amps. For impedances, you have ohms. And for power, you have watts and so on. So this is something we're all very familiar with, right? The second method of defining electrical quantities is this per unit method. And let's begin by defining per unit quantities, what they are. Oops, my handwriting is horrible, but hopefully you understand. So units, which we are aware of, and second, per unit quantities, which we're going to define today. The definition is very easy, and it's also the formula that we're going to use to really calculate them, and I want you to remember that formula. So basically what it says is per unit, I'll write the whole thing down, per unit value is the ratio of the actual value. So let's say you have a voltage, the act in volts, so the actual voltage in volts divided by a base value, right? Which implies, so if I have the actual value, this is how I will calculate my per unit value. What if someone gives you the per unit value? Well, in that case, it's obvious from this formula, the actual value is nothing but the PU value, which is the per unit value, which you will, this is how you will see it being written many in most places, just PU. Oops, sorry. It'll obviously not be divided, it'll be multiplied to the base value, right? These are the two formulas I would like you to remember for the rest of our discussion on per unit quantities. So again, just to define what it is, a per unit value is the ratio between an actual value and the base value. Therefore, you can also relate to it as it's also related to normalization. You're normalizing an actual value around a base value or a percentage value. And that'll become clearer with the example that I'm just going to give you. So let's do a quick example to understand what we just defined and how we can use that how we can use this. So let's do a quick example. Let's say you have a bus. So you have this bus 1 connected the transmission line to a bus 2. So this is bus 1. Let's say it is at 110 kV. And this is bus 2, and this is at 90 kV. Now, before I go any further, if you're very new to power system analysis, this might look different or new to you. You might not be used to terminologies of buses and seeing this a diagram like this with lines. This is basically a single line diagram. Uh, it's an easier representation of a power system network. So rather than drawing, for example, each and every parameter in a network, or we define it easily using we draw it easily using a single line diagram. And don't worry, we will come to this discussion down the line as we dig deeper into power system analysis. For now, imagine this is just a node in a power system where the voltage that you measured is 110 kV, and it's connected via transmission line to another node or another substation where the voltage you measured is 90 kV, right? What we're trying to understand is how will we convert these values on bus 1 and bus 2 into per unit values. So the first thing we need to do is define a base value. So let's say for this is your whole power system. For this whole power system, I'm going to define a base voltage. I'm saying my base voltage VB is 100 kV, right? Okay. Now that I have my base voltage, I am going to get my per unit value. So my voltage at bus 1 in terms of per unit is going to be the actual value, which is this 110 kV. So I'll come say 110 kV over my base value, which is this 100 kV, and that is equal to 1.1 pu or 110%. Remember how I mentioned about percentage here or normalization? So these are the two other things that that can relate to per unit value, and that you'll see being used as well. Voltage on my bus 2 in terms of per unit is 90 kV over 100 kV, which is equal to 0.9 per unit or 90%. So that is relatively simple and straightforward, I hope, and it's easy for you to understand that if you're given the actual value, you define a base value for your system, and then you calculate your per unit value from that base value. And that's all that there is actually really to per unit quantities. Of course, now the question is why we end up using them, what is the benefit of using them, why even bother doing this in the first place, right? And these are questions that I will answer in the following videos, and that will become very clear to you because we'll again go back, solve some examples, and they'll become extremely clear as to what the advantages are, how it makes our calculations a lot easier. One of the biggest advantages, for example, is when you have transformers, and on the primary and the secondary side of the transformer, it basically makes the transformer vanish in when you're doing calculations, when you're trying to find out the load flow and things like that. And that's the beauty of them. So hopefully you understand what the definition is, how to use that definition, how to convert actual values into per unit quantities. So what I'm going to do, as promised, is I'm going to leave you with a sample problem. So I'm going to leave you with a sample problem. What I'd like you to do is solve the sample problem, see what answers you get, leave those answers in the comment sections below. I will be visiting these comments from time to time on a regular basis, and if you have any problems understanding it, or if your answers for some reason you think they don't make sense, I will definitely comment on you. I'll get back to you and see where we're having the problem. So let's see, the sample problem is you have one circuit, so that's circuit 1, and you have another circuit, that's circuit 2. What you're given is I1 is 5 amps, I2 is 20 amps. What you're also given, your base current is 10 amps. What I'd like you to find is what is I1 in per unit and what is I2 in per unit. Those are question marks there. So hopefully I've given you enough information to solve this. It's very easy to solve from here. So as I said, solve these. If you have problems, or even if you don't, I want to see your answer in the comment section, and then we'll go from there. Do visit the next video, that will give you a deeper understanding. We'll go in a little bit more concepts, and we'll solve some more examples. All right, thanks for tuning in, and take care.